Algebra Unit 10, Lesson 8, Notes 8, Solving Quadratics with the Quadratic Formula. Completing the square of the quadratic equation ax squared plus bx plus c equals 0 produces a formula that allows you to find the solutions of any quadratic equation. This formula is called the quadratic formula. So the solutions of a quadratic equation, ax squared plus bx plus c equals 0, where a doesn't equal 0, are given by the quadratic formula. So this right here is our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, negative b doesn't mean you make the b value negative, it means opposite. So if b is 2, for example, you would put negative 2. However, if b is negative 4, it would be negative 4, which becomes positive 4. So again, the negative b doesn't really mean make it negative, it means do the opposite. So let's take a look at some examples. Solve the following equations using the quadratic formula. Find the exact solutions. Remember to set the equation equal to 0 when necessary. Here's the key, exact solutions. So there will be some instances where we will have radicals in our answer, and that's okay. All right, let's try letter C. Let's start there. So here we have, the important thing is to make sure that you're in descending order, which we are. So this would be our A, our B, and our C value. Remember, there's an invisible 1. The quadratic formula is nice because it works with absolutely everything, and the formula is given to you. So we have x equals negative b, means the opposite of negative 12. So 12 plus or minus the square root of b squared, so negative 12 squared, minus 4 times a, which is 1, times c, which is 20, all over 2 times a, which is 1. So 12 plus or minus. Do what's under the radical. You can plug that whole thing in your calculator, but you need to make sure you have parentheses. Because remember, negative 12 squared is really negative 12 times negative 12. If you do not have those parentheses, you will end up with an incorrect answer. So parenthesis negative 12 parenthesis squared minus 4 times 1 times 20. So under the radical, we have 64, which is a perfect square, so that's what we want to see. And 2 times 1 is 2. You won't always get a perfect square, and we'll do some examples of that in this lesson. So x equals 12 plus or minus. Well, the square root of 64 is plus or minus 8, thus where the plus or minus comes from in the formula, all over 2. So what this really is 12 plus 8 over 2 and 12 minus 8 over 2. We can do those calculations. 12 plus 8 is 20, divide by 2 is 10. 12 minus 8 is 4, divide by 2 is 2. So the solutions, or the roots, or the zeros, however you want to word it, are 2 and 10. Letter D. Sometimes you will have to put it in descending order. You need 0 on one side of the equal sign. So I will add 5x. I'm going to squeeze that 5x in between those two terms. So 3x squared plus 5x minus 12 equals 0. We have A, B, and C. What's another benefit of the quadratic formula is we don't have to factor anything. It's essentially just plug and chug. Negative b, well, b is 5, so negative b would be negative 5 plus or minus the square root of b squared, so 5 squared, minus 4 times a is 3 times c is negative 12, all over 2 times a, which is 3. X equals negative 5 plus or minus. Under the radical, when you plug all of that in, we get 169 all over 6, 2 times 3 is 6. Square root of 169 is a perfect square, which is 13. Negative 5 plus or minus 13 all over 6. So again, this is negative 5 plus 13 over 6. and negative 5 minus 13 over 6. So we get 4/3 here and negative 3 here, which means my roots are negative 3 and 4/3. Let's look at H. Again, I need to have 0 on one side. So 2x squared plus 9x minus 18 equals 0. A, B, C. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Make sure you're plugging in the correct numbers. Okay, when we do the calculation under the radical, we get negative 63 all over 4. You should notice an issue. We cannot have a negative under the radical. If you put square root of negative 63 in your calculator, it will come up non-real. So we can stop right here. This has no real roots, which means the graph never touches the x-axis. Letter J. This is already in descending order. We have A, B, and C. It's already equal to 0 as well. So x equals negative b would be positive 2 plus or minus square root of b squared minus 4 times a times c all over 2 times a. Under your radical, you have 112. And the denominator is 6. Now, 112 is not a perfect square. It is also not negative, so we have to break down 112. Think about the perfect squares that go into 112. You want the largest one. The largest one is square root of 16, and that times 7 gives you 112. Square root of 16 is 4, so this is 2 plus or minus 4 radical 7 all over 6. Now, each term here, 2, 4 radical 7, and 6, the numbers outside the radical in each and every term are divisible by 2. So you can actually divide by 2. So if I divide each of these by 2, I am left with 1 plus or minus 2 radical 7 all over 3. And those are your roots. We can leave it just like this. Because our roots are 1 plus 2 radical 7 over 3 and 1 minus 2 radical 7 over 3. So again, make sure if you have a radical and it's not a perfect square, you need to simplify it if possible. And then simplify any of the terms if you can. Letter L. Again, we're all set up here. So x equals negative b would be 4 plus or minus square root of negative 4 squared minus 4 times negative 11 all over 2 times 4. X equals 4 plus or minus. When you do everything under the radical, you get 192. This is all over 8. 192 is not a perfect square, so we need to break it down. 192, the largest perfect square that goes into 192 is 64. And 64 times 3 gives us 192. Square root of 64 is 8. Bring down the radical 3 and everything else. These are all divisible by 4. So we have x equals 4 divided by 4 is 1, plus or minus. 8 divided by 4 is 2, radical 3, and also 2. Notice how I didn't touch the radical. You can't divide a radical by a regular integer. So our roots here are 1 plus or minus 2 radical 3 all over 2. In the quadratic formula, the expression under the radical sign, b squared minus 4ac, that part is called the discriminant. The discriminant can be used to determine the number of real solutions of a quadratic equation. So sometimes you'll see a multiple choice or a part 2 question that asks you how many solutions a quadratic has. If it's asking for how many and not exactly what they are, you can just use the discriminant to do that. It saves a little bit of time there. So if our discriminant is negative, that means you have no real roots. And notice on the graph how it doesn't touch the x-axis. If you get 0 as your discriminant, that means it touches the x-axis at 1 point. Lastly, if you get any positive number, that means you have 2 solutions. So let's use the discriminant to determine how many roots each of these have. Let's start with A. We still need to be in descending order, and we need to have equals 0. We are still labeling A, B, and C. But we are just using b squared minus 4ac. b is 5, so 5 squared minus 4 times a is 4 times c is 3. Plug that whole string in your calculator. In this instance, I get negative 23. And the directions want the discriminant and for you to tell how many solutions. If you look at your chart, a negative discriminant means that there are no real roots. Again, this doesn't tell you what the roots are. It just tells you how many roots there are, meaning how many times does it cross the x-axis. Letter C. We need to have 0 on one side, so let's add 25. 9x squared minus 30x plus 25. Our discriminant is b squared minus 4ac, so negative 30 squared, and please put it in parentheses. Minus 4 times 9 times 25. Plug it in your calculator. In this instance, we get 0. Looking at your chart, if you get 0, that means there is 1 root. You could also say solutions, whichever term you would like to use. Letter E. I'm going to subtract 11x from both sides, and I'm also going to add 10 to both sides, and I'm going to do that in one step here. So 2x squared minus 11x plus 10 equals 0. B squared is negative 11 squared minus 4 times a, which is 2, times c, which is 10. Plugging that into the calculator, we get a discriminant of 41. And because it's a positive number, that means there are 2 real roots. Again, you can also say solutions. Go ahead and try the rest of these on your own.